0 be?
4.
How'd you get that? How'd you not?
Wouldn't that be 0? Why would you pay anything for no gain?
Okay, so we addressed that in the last class too. Okay, why is the cost of 0 4? How many of you guys shop on Amazon?
They charge you to look at it?
No? Right? No matter what, before you buy something, they say you're going to pay this much for shipping no matter what. But then as you add things on, the shipping cost might change. Okay, so there's always that base shipping cost. And then it changes based on, it's typically weight, not per item.
If you order more than $30 of stuff, you get free shipping.
Exactly. But we're not, that doesn't help us in this math problem, right? That kind of throws things out. Okay, so you gotta play along a little bit. Gotta play along a little bit. I know it's not completely accurate. Alright, but how'd you guys find 6 and 4? Those are you guys that told me?
Well, one of those things is inaccurate already. It's Xbox games. I'm not going to be buying Xbox games ever.
Alright, whatever. We're past that. We're past the problem not being 100% real life accurate.
That's capital X.
Okay? How did we find 6 and 4? Jackie?
You just subtract 2.
Okay, subtract 2. Okay, or if we're going down the table, what am I doing, Jackie?
You're adding 2.
Adding 2. Very good. Now my question is, what is our rate of change in this problem? To what? $2. What? I heard it over here. So what is our input? Carmi, what's our input? Robbie, don't talk.
Wait.
Carmi's right. What's our input? What would our list of x values be?
Number of games.
Not the number, just in general.
In general?
Yeah.
What?
No, so if we have x in an equation, what is x going to represent? The number of games. So that's our input, right? The number of games. So what's the output, Carmi? Total cost. Okay, good. So now, okay, the start value, right, we found it earlier with the cups. What would our start value be here? Natalie, what do you think our start value would be? 4. Why 4? Say that one more time.
Because you have 4 automatically.
Right? The zero cost or the 0 gains is $4. Okay, that's our base or our start value.
You're so
Pay attention, you're right. Doesn't matter. Alright, so what does the start represent in this equation? You just said it. What did you say?
It's the starting price for shipping.
Okay, good. I'm going to say the base price. Base price for shipping. So now we need to come up with the equation. So what I want you to do, everyone, in their notes, in your notes right now, write down an equation. From this table, from what we did. Even if you're not sure, okay, try and take a guess. But I want everyone writing something down right now. Writing down an equation.
It's in my head.
I want you to write on paper. Take a guess. Take a guess. Write an equation. Yeah? You're going to be the only one that sees it, but it's important that you try it.
I know the equation.
Remember that.
Sure I did. I slept up as far as I could with that ruler.
Oh, this is so easy. The shipping of 12 games is $32.
Yeah, well, I'll ask you how you got that in a sec, though.
Careless.
All right. Victoria, what did you write down? Y equals 2x plus 4. Where did you get the 2 from? $2 per game, which is our what? The rate of change, right? Good. Where did you get the 4 from?
From the 0 starting point.
The start. Good. Everyone see that? Where she got those two values from?
Yes, sir.
Okay, so the next thing I'm about to write up is very important. Okay, it acts as just like a template on how we can write equations from a table. Okay, so our y value, what does that also represent? Our list of what? Outputs. Okay, so I'm going to write output equals, what was the 2 in our equation? Victoria, what did you say our 2 came from? Rate of change. Okay, what comes next? What do we do with that rate of change? What you said? Somebody whispered something that I liked. Carmen, is that you?
At 4.
What?
Who whispered something in the middle right here? Did you just still up?
Multiply it by 12.
Louder!
Multiply it by 12.
Okay, that's to solve this one, but just in general. What is that 12?
Number of games.
Okay, what is the number of games represent in our problem?
Input.
The input. Now what's the last thing? Isaiah, what's the last thing we do? What are we missing? Because right here we have our output, rate of change, and input. What is that for?
Oh, the money we started with. So.
Good, so let's start. Let's start. This absolutely should be in everyone's notes. Because as we move through the unit, okay, if you guys are asked to write an equation given a table, I'm going to ask you, what are these 3 or what are these 4 things? What's your start value? What is your input? What is our rate of change? And what is the output? Is this, are we always going to add a start value? Is it always going to be a plus?
No.
Sometimes it'll be minus, right? Sometimes we'll be starting with less and adding and increasing. Or maybe even decreasing. Okay. So let's predict the cost of 12 games.
$32.
Brian said $32. How'd you get that though?
Multiply the 6.
Huh?
Multiply the 6 output.
Oh, so you just doubled this?
Yeah.
You get 32?
You basically put the answer on the board.
Okay, so you just said 16 times 2 equals 32. Is that right? Chase, you just shook your head. How would you have done it?
I think it's 28.
Yeah, that's what I thought too.
Because you're doubling the starting cost, and so you have to minus 4 from 32 to get 20.
Right, and if we think back to our lesson with Lady Gaga, Justin Timberlake,
Yeah.
and who's the other one? Mr. T. That's what Justin Timberlake did, right? You're paying, when you double this, you're paying for the base shipping cost twice. So you're adding an extra $4 on. Okay, so for those of you, Gabby, I heard you say you agreed with Chase. How'd you get that value though?
I added 2.
Huh?
I added 2 each time.
Oh, so you just kept going, you just kept increasing? So you did like Mr. T. Right, that's what he did. But luckily for you, you didn't have to do it a bunch of times.
Yeah.
Chase, how'd you do it?
I did exactly what Brian did. I did 6 times 2 and then 16 times 2, and then I knew that was going to double the cost.
So you just subtracted the 4 away?
Yeah.
Okay. Somebody else, we're still not quite.
2 times 12 plus 4.
2 times 12 plus 4, why'd you do that?
I don't know.
You don't know? Right, that's the equation that we just created. Right, we're multiplying our rate of change, which is 2, times our input, the number of games, which is 12. We're adding that base cost. 28. And in this problem, do we say y equals 28? What should we say? Robbie?
Cost of 12 games equals
28 what?
2,800.
Sounds good. Everyone kind of see how we can relate the table and the equation and where the rate of change comes from?
Yes, sir.
Alright. We're going to do the same thing with this multiple choice question. So once you have an answer, put your head down. And then I'll see who votes for A and who votes for B. So the question asks, what does the highlighted row represent? Is it A, in year 2, the height was 52 centimeters? Or is it B, when the years change by 2, the height changes by 52 centimeters? Once you come up with your answer, put your head down.
I'm ready.
Make sure we all vote this time, Robbie.
Okay, so,
Alright, raise your hand if you think it's A in year 2, the height was 52 centimeters. Raise your hand if you think it's B, when the year changes by 2, the height changes by 52 centimeters. Alright, put your hands up. Not everyone voted again? Come on, participate. Alright, you guys nap for a quick few seconds? Let's go. Alright, so, what was it? Is it A or B? A. Pretty much everyone said A. There fellas said B. But why is it A? Why is it A?
that's literally
the
what
start.
Is it the start?
It looks like the start.
It's the start of this table. Yeah, but usually our start comes from the 0, right? When our input is 0. So it's not the start, but it's just the value in this table, right? That's all it is. If I were to highlight 8 and 94, that's not the rate of change, it's just the value in the table. Okay, so that brings us to our next question.
Or head fully down.
Yep, we'll do it again.
Yeah.
So it says, what do the 3 and the 21 represent? The 3 being these over here, and the 21 being these over here. Is it A, in year 3, the height was 21 centimeters? Or is it B, when the year changes by 3, the height changes by 21 centimeters? Put your heads down once you have an answer. Alright, raise your hand if it's A, in year 3, the height was 21 centimeters. Raise your hand if it's B. Good, everyone said B, you can put your heads back up. Excellent, right? So our rate of change, wait, we haven't even used the rate of change, right? It's just saying that when the year changes by 3, right, our total, our height is changed by 21. Okay, so now my next question is, what is our rate of change in this problem? And how do you know it? Can we find, do we have enough information to find the rate of change?
Yeah.
Yeah?
That's it.
Huh? What is our rate of change?
Height per year.
So height per years, okay.
Or years. Yes,
I'm looking for a numerical value though. Yeah, Chase?
7.
7. How'd you get 7?
Dividing 21 by 3.
Good. What does the 21 represent?
The height of the change centimeters.
Yeah, how much is changing each time? What does the 3 represent? Huh? The years between. Alright, so what, in terms of inputs and outputs, how can I change this? Right, what did you just say the 21 was? It's the height. Is it the height of every year?
No, it's different.
Difference or the change? Right, so just in general, huh? In general, what is this 21 going to represent? Jackie, you have an idea?
21 is the change of the height from each year, and then the 3 is just
What is the height in terms of our y values, inputs, outputs? What does that height represent? Is it our input or is it our output?
it's our output.
Output, good. Now I love that you use the words change in. So change in output. So what is that going to make the bottom? Friends?